Walter here at Crystal Instruments. Last episode we showed you how to prepare a modal test. In this episode we're going to demonstrate how to acquire modal data using hammer impact.
Hammer impact tests are typically done with a force sensor, such as a modal hammer to measure the excitation, and one or more accelerometers to measure the response. There are two methods, and both methods use excitation as the reference.
The first method is the roving hammer method, in which you use a modal hammer to excite the structure at various measurement points. The response points are fixed. The second method is the roving response method, in which the excitation points are now fixed, but the responses are measured at several points. For this video, I will demonstrate the roving excitation method. To start the test setup, open the New Test wizard. There are several test types listed here. These will determine how the modal data is obtained. We need to select hammer impact for this test. We also need to generate a 3D model. If you have the file available, you can skip the process of creating the 3D model. Press the Choose button to locate the model file, and then follow the remaining steps from the test wizard. The geometry editor shows a preview of our 3D model. We can check how the degrees of freedom, or DOFs, correspond to the measurement points on the structure under test. Since we don't need to make any changes to the model, we can skip to the input channel configuration. First, enable the input channels using the checkboxes. Here we will only be using 2 channels, so we'll disable the others. Set the sensor sensitivities for each channel, as well as the measurement units and input modes. Now we will configure the analysis parameters. Click on the Measurement tab. This is the interface that is displayed during measurements. The testing status shows which points are completed and which ones still need to be acquired. The control panel, shown on the right part of the screen, is the interface through which you can start, stop, and configure tests. The analysis parameters are located directly under those main control functions. Configure the various parameters according to the test requirements. Since we'll only be doing a roving excitation measurement, we must set the roving mode accordingly. Now return to the input channel setup to configure the DOFs. We must assign a measuring point ID and increment point for each channel. Since this is a roving excitation test, we must ensure that the excitation channels are always assigned to the appropriate points on the structure. The measuring point ID represents the DOF point number. Since we will start at point number 1, we need to choose this number as the measuring point ID for our excitation channel. We will be changing the point of impact by 1 measurement point, so we need to configure our excitation channel to have 1 increment point. The increment point refers to how many points will be incremented for each test run. The increment point is set to 0 for our response channel and 1 for our excitation channel. Now return to the measurement screen to proceed with measurements. Now that the test parameters have been configured, we can start the test. Press the Run button to start the test. The trigger window shows that it's ready to acquire the signal. Excite the structure using the modal hammer. The trigger preview window shows the measured impact and response signals. After reviewing the impact signal, we can choose to accept or reject the signal. The rejected signals are discarded from the averaging process. Once we reach the average number, the trigger window will close and the averaged FRF data will be saved. Move the hammer to the next excitation point. As you will notice, the excitation channel measurement is then increased by 1 to reflect the new measurement point. We can check the testing progress on the left of the display. We continue this process until we've acquired all the measurement points. Once all the points have been measured, we can start reviewing our acquired modal data. Click on the Modal Data Selection tab. The Modal Data Selection tab is where we manage our testing data. This list shows all the FRF measurements that were acquired during the test. We can import FRF signals to this list, and we can also remove FRF measurements. To repeat or replace a measurement, there is no need to delete any previous FRF measurements. We simply need to acquire a new FRF and it will replace the existing FRF for that particular DOF. For example, suppose we replace our modal data for point number 5. To reacquire the modal data, we need to reconfigure the input channels for the appropriate measuring point ID. I've only enabled 1 response channel because we only need to replace 1 measurement. When I need to repeat the measurement at point number 5, this replaces the old FRF. Once complete, the new FRF will replace the old FRF in the Modal Data Selection tab. You can see that it allows only one FRF signal for any given point. This concludes the modal data acquisition process.